Okay, I think everyone's now joined us, Lev. So I'm going to kick off. Hello, everyone. My name is Katrina Sluis, and it's great pleasure to welcome you today to this keynote by Lev Manovich. Today's talk is organised by the Visual Narrative Research Group at Lucerne University of Applied Sciences and Arts. It forms part of a program of talks and events connected to two different things. First of all, an SNSF funded project curating photography in the networked image economy led by Dr. Wolfgang Brückle, which brings together photography curators, social media misfits, and computer scientists to critically examine how to curate ubiquitous post-photographic culture. And I'm pleased to see many students in the audience today. And this is really crucial because today's event forms part of a week-long festival associated with the graduating students of Lucerne University of Applied Sciences and Arts. And in the chat area, you can read more about the program and you can learn how you can view their work online and also see some of the other talks that are happening this week. So I'm really pleased that I can see colleagues from both Europe and the Southern Hemisphere in different time zones and countries beyond Switzerland. And our speaker, Lev Manovich, is zooming in from South Korea. And I'm joining you from Canberra, Australia. And I'd like to acknowledge the Ngunnawal community, who are the traditional owners of the land from which I'm speaking today, and pay my respects to their elders past and present. And before I hand over to Lev, I'd like to make a few requests. Firstly, the talk is being recorded, so please don't share any of your deep and dark secrets with us in the chat. And please, can you ensure that you have your microphones off and be prepared to turn off your cameras should we have any problems with bandwidth or technical issues. I'd like to invite you all to please raise questions in the chat if they occur to you during Lev's talk. And we will gather these together at the conclusion for Lev to respond to. So without further ado, it's my great pleasure to introduce Lev Manovich, who will be speaking to the following questions. What does data want? Can we think without categories? And can computer vision help us understand art? Lev is one of the leading theorists of digital culture worldwide and a pioneer in the application of data science for analysis of contemporary culture. Manovich is the author and editor of 13 books, including AI Aesthetics, Theories of Software Culture, Instagram and Contemporary Image, Software Takes Command, Soft Cinema, Navigating the Database, and The Language of New Media, which was described as the most suggestive and broad-ranging media history since Marshall McLuhan. He was included in the list of 25 people shaping the future of design in 2013, and the list of 50 most interesting people building the future in 2014. Lev is a presidential professor at the Graduate Center, City University of New York, and a director of the Cultural Analytics Lab that pioneered analysis of visual culture using computational methods. So on behalf of everyone here, I'd like to welcome you, Lev. And Lev's going to speak for around 45 minutes to an hour, and we'll have about half an hour, give or take, for discussion. So thanks very much, Lev.
So thank you so much for inviting me, and very happy to be speaking to this global audience with kind of European focus. So I'm going to juggle between my website, a PDF of my new book, and 3 keynotes, because I feel I'm talking to the closest colleagues, right? Katrina can explain to me what you know everything about my work and all my darkest thoughts, and what I don't know about yet. So I kind of want to make my kitchen, right, visible, to present to you, in fact, my doubts, my hesitations, and that's why I'm speaking to you from the kitchen, right? I noticed on Zoom there's a strange kind of iconography. Everybody, like all the announcers, news, all the academics speak and we have some kind of fake bookshelves. I don't know why. I haven't been to a library in 15 years, just because I travel so much. So I think kitchen is actually a better metaphor, right? And I'm thinking when I was a teenager in Russia, in the romantic and dark and very special days of communism, all the intellectual life took place in the kitchen. So in a way, like we're back now, right? Speaking from our kitchens, bathrooms, bedrooms, and some people even have bookshelves. Okay, so first, I want to tell you a bit about my biography, because you will understand that what I've been doing in the last 15 years is a completely logical outcome of what I was trying to do, or I was trying to arrive at on my life. And whether I'm in the right path, I don't know, but I was on kind of one path for 50 years. So like I have two different kind of timelines, right? One is like the official one, and then the intellectual one. And I think both together will kind of tell you a bit about myself. So born in Moscow, 1991, came to New York, went to NYU, New York University Film School, got bachelor degree. From 86 to 88, I was a PhD student in vision science. Vision science is a part of cognitive science, right? So it's an intersection of human psychology, kind of study of perception, AI, trying to understand how human visual system works, but approaching it as a kind of information computer system. So after 2 years, I realized that I don't want to be a scientist because we just work too hard. We do work harder than anybody else, including artists, humanities, and definitely politicians. And then I decided to go back to humanities. So I was the second person in the world to get a PhD in visual culture. And my program combined history and theory of art, film studies, and literary studies. And then for 20 years, I was a professor of visual art. And for a large part of this period, I was kind of focusing on being at the beginning of so-called new media art, new media theory, visual culture theory. And most of my classes were basically practical classes, right? I never had a job as a theorist. Basically, my job was as an artist, right, because of my art and design background. And my so-called new media theory, language of new media, it was a bit different, right, from typical academic theory, where academics talk to other academics. I'm basically an artist who talk to other artists. So I wanted to create a set of concepts to help other people who are working in digital art, digital design, to have a terminology. And then in 2013, I moved to New York, and I've never taken a single computer science class in my life. I became a professor in the PhD program in computer science. So that's what I'm kind of my formal biography for the first 6 years of my life. Now comes kind of second timeline, which is more about concepts. So at the age of 13, right, I started very serious art lessons in addition to my kind of normal high school. My high school was also special. So in addition to regular subjects, I had 20 hours of calculus every week. And at the age of 15, we started learning computer programming. And then after about 5 years of doing art, I realized that doing art itself becomes a bit boring to me because I said, I kind of know how to make, a good, decent painting, but what makes it a decent painting, right? And you have to understand that my art teacher, she, as an example of good art, she showed me kind of modernism. So people, especially like Morandi, right? Kind of semi-figurative, semi-abstract painting, which on the one hand represents familiar objects, something you'll find in the kitchen. On the other hand, it arranges colors, shapes, lines, right, in some kind of balance. And I realized that for the rest of my life, unfortunately, I can't make art. I mean, I will make art, but what I really would end up doing for the rest of my life is being tortured by these questions: how images are structured, how they work, how we communicate, why some images are better. But basically, right, how to use the language of 20th century, right, how the images are structured, how we create meanings, how they affect us. Maybe this is not necessarily the questions you want to ask today in 2020, but this was the language I learned. And I started to look, right, for kind of intellectual models to help me think about it. And I came across semiotics. and psychology of art, people like Rudolf Arnheim. And these two models, in a way, were guiding me, in my 20s. So when I came to New York, right, and something else happened in 1982, in the age of 22, I saw first very early computer graphics, right, 3D computer graphics. And I realized that one day, with computer-generated imagery, 3D graphics, 3D animation, and so on, would become as important, as drawing, paintings, photography. And I think it was a kind of daring idea, because I think when I first started to work in the first company, when I got my first job doing 3D computer animation, where I basically had to make 3D, three-dimensional objects for commercials, and I did commercials for Nike, Adidas, IBM, Kodak, hundreds of commercials, right? Maybe about 40 people in the world were working in this field. So to realize in 1984 that this is something I want to also be doing for the rest of my life was a kind of, I was pretty early. So then, I still was kind of wanted to figure out how I can pursue my theoretical interest in how images work. So I went into a PhD program in vision science, and I was really lucky that in 1986, right, so it's like almost 34 years ago, I took my first PhD classes in computer vision, right? So today, computer vision is more and more ubiquitous. It's really becoming part of everyday life. In the last 2 years, it entered the world of culture, right? But who kind of was thinking about computer vision in 1986, right? So for like all these years, right, I kind of wanted to figure out how to study images, how to study visual semiotics, how to study visual communication. And by late 20s, I realized that semiotics is a kind of dead end, because it's kind of impossible to understand how a single image works, because its meanings effects are too contextual. And I said, okay, I can't really understand how a single image works. It's too hard. But now there's this new thing going on, which is digital media. In fact, the term new media was kind of first introduced in English language in 1990, 30 years ago. So I said, I'm going to do something easy. I'll become a theorist of new media. So while I can't really understand, and I can't theorize better than Roland Barthes or Julia Kristeva, or Marshall McLuhan, how images work, maybe I can do some useful work to come up with concepts which will help me and other people working with digital images to think about them, right? Concepts like database, interface, navigable space, et cetera, et cetera. Yeah. So on the one hand, right, I still have my interest in trying to understand how images, visual communication, visual culture works. On the other hand, right, I'm kind of doing this parallel track in new media, in digital culture. And for a while, right, there was no connection until 2005. So by 2005, on the one hand, the computers are becoming fast enough. So there is a finally beginning of some progress in artificial intelligence. I mean, you couldn't expect any progress in AI the first 40 years because the computers were just too slow, right? And it becomes possible to actually do computer vision not on 1 or 2 images, but on thousands of images. Recently I looked back at the articles from about computer vision field from late 80s. So somebody proposing new line like segmentation algorithm or line detection algorithm. And then there's an article, right, published in ACM, and as examples we just apply to like 3 images literally, because that's all the computers can do. So there was no way me or nobody else in 1985 could think about cultural analytics, right? But in 2005 it became possible. So in 2005 I kind of had this idea. So it's almost right exactly 15 years ago. I said, there are 2 things going on. The scale of culture is increasing exponentially in front of my eyes, because in 2005 it becomes possible to add images to blogs. There was already Flickr, but only 3 million users, so social media was not very visible. But already museums like MoMA or ZKM had websites. Already some artists had websites. You already had not Behance, but websites like Behance, where creators would share their portfolios. So already the web was becoming, right, a very significant kind of window into the contemporary visual culture in visual production. On the other hand, you have computers, we're faster, right? We have enough RAM. I said, oh my God, let me put two and two together. So what I'm going to do is I'm going to work with computer scientists and figure out a system, right, which will allow me to download images, video, web pages, thousands, millions, billions of them, even using the techniques of kind of media computing, like text processing, network analysis, and computer vision, right? Analyze them and figure out trends, patterns, and so on. Now, my idea was, again, right, was a bit big. So I don't think I'll be able to realize it in my lifetime. But the idea was kind of, in a way, was very simple. So I said, you know, why don't we basically create a software which will be downloading or indexing every single image being shared today. So images from Hollywood movies, images from Netflix, images from students, right? Images from student classes, images from Flickr, there was no Instagram yet, right? Images from artists. You know, and then using computer vision and text analytics in our techniques, you know, basically extract trends, patterns, and we'll have like a real-time dashboard, like I have Google Analytics dashboard, because Google Analytics, in fact, came out as a product in 2008, but for culture. So the idea was, why not create a system which allows us to observe contemporary culture at a global scale, where we can zoom in, right, into any city in the world and see what's going on, see the images people create, and zoom out. Now today, 15 years later, right, it's actually possible to build it. And actually, I can give you a budget, right? Probably we can build it for less than $1 million, but then we'll still probably need $200,000 to $300,000 to maintain it. But basically, it can be built, right, with kind of a few programmers. But of course, we'll not be able to process even a very, very small part of all the images being shared today, right? Because as we know, Instagram alone, there's 90 million images per day. There's a couple of billion images on Facebook, and of course, there's WeChat and so on and so forth. So, so obviously, as the ability of computers to process, index, and organize information online have been increasing, the amount of information kept growing. Anyway, so this is a bit of a story, and I like to I wanted to spend some time on it because I think it's interesting to students. Because as a student, right, I was really tortured all the time, right? Because I was interested in kind of theory, how visual communication works, how images work. I was interested in making art, right? So I studied art, painting, drawing, engraving, etching. I studied architecture, filmmaking, right? Video art. And then I was doing all this kind of digital media, right? And also I was doing cognitive science, and I was always trying to figure out how to bring it all together. So as new media first, the cultural analytics later has also become a way for me to bring my very diverse interests around both observing and trying to understand contemporary visual culture. And the idea is that, in my late 20s, I realized that the existing tools of semiotics, psychology of art, philosophy in our traditional disciplines are not good enough to help me understand how a single image communicates. So I said, okay, but maybe I can work on an easier task. I can use the tools of data science, try to understand what images people create today at the rate of probably many, many billions per day. Okay, so very briefly, I will show you this book of mine, Cultural Analytics, which is coming out in October from MIT Press. They sent me like a new edit on Friday, so I have to return it, in fact, today. So I mean, it's another proof. So first time they sent me the edit, it was like, we made 13,000 edits. Second time it was 2,000, now it's only 100. So basically it's written for students and for everybody else. It's written both for humanities people, for photography curators, right? For wondering what to do with collections, and also for web designers, marketing people, to help understand something about cultural images. And so the first chapter, right, from new media to more media, it's a kind of my description of what happens in 2000, right? And then wondering if we have so much of media, so much of cultural artifacts being created now. I mean, trillions of artifacts, messages, interactions per day. Does it mean that we can think of culture as a kind of science, since we have so many with cultural artifacts, maybe we should look for some laws. And when I talk about how, of course, the computational analysis of media has become a new foundation of culture industry, right? I mean, search, recommendation engines, you know, recognition of faces and smiles on camera. So today, media is based on media analytics. And when I focus what I think is the key question, so if you want to approach culture as data, if you want to kind of throw the data science tools, paradigm and method, and you want to study history of art or contemporary visual art, or design, or web design, I don't know, or t-shirt design, or crafts, or, you know, IKEA furniture, or Netflix, you know, or anything you want, right? So what do? How do you go from culture, which may involve processes, experiences, you know, going to a club, right? I mean, watching a theater performance, playing a video game. How do you move from these experiences to something which data science knows how to deal with, which is data? And that, to me, in fact, is the biggest question, right, of cultural analytics. And that's one of the things which separates it from digital humanities. The digital humanities were too conventional, right? We say, okay, we have been studying, you know, paintings and kind of works of architecture and sculpture and images. So now we'll have digital files, and we just going to look at digital files. But we're kind of throwing away the most interesting question, right? How do you conceptualize, again, going to a club, participating in some interactive event at a city festival, playing a video game, I don't know, going to a ZKM, right? And interacting with some 90s interactive installations, designing something and processing or D3, looking at paintings, right? How do you turn these processes and experiences into the data? So I talk about types of cultural data. When I talk about the idea of cultural sampling, right? One of the useful ideas which come to us from science is, instead of studying something we like because we think it's important, which is what humanities people have been doing. And of course, if you study something you like, typically means you're basically just a subject of ideology, right? Because it's the ideology which tells you what's important, right? You know, so how can we study everything, right? If I want to look at every single image being today, why it's a good idea, and so that's why we need big data. And when we talk about, again, I'm taking the concepts, right, from kind of data science workflow and trying to humanize them, trying to rewrite them in relation to thinking about culture, right? So we're talking about, like, what's the first thing you do with data? You have metadata, but you also extract features, right? And what are the advantages of representing, you know, image characteristics as features, right? Well, we have a dive into philosophy, cognitive science. And then we talk about, so now what you represented your cultural experiences, artifacts, histories as data, what the first thing you do? Do you run your neural networks? No, of course not. Because if you want to classify something, it means you already missed the most interesting part, which is the ability to use computers to look at something in a new way, right? So we don't want to classify things. What we want to do is engage in what in data science is called exploratory data analysis. But I kind of changed this concept, and I made a new one called exploratory media analysis. So the last part of the book talks about this concept, and specifically focusing on the exploratory media analysis or visual media. It talks about various projects of my lab, you know, and various techniques, you know, such as PCA or t-SNE visualizations, right, which allow us to explore large image and video sets, and, for example, group images by similarity. So that's a book. Okay, now we're done with it. So now let's talk about the key theoretical idea. So in the last 15 years, I'm not the only person, of course, who got this idea that we can treat kind of culture as data, and we can apply kind of data science ideas and assumptions. Right? As I already mentioned, this idea is basically a foundation of contemporary consumer society, right? Maybe it is Facebook algorithm, which can recommends, right? Which selects which updates to show to us, right? Or Instagram algorithm, which selects which photographs to recommend to us, right? So recommendation engines, search engines, the various algorithms in the cameras, in Photoshop, in Google Photos, in IAM, right? And other services which use computer vision to, for example, categorize the content images and to even give them a static score, right? So, basically what I call media analytics, the computational analysis of media, right, has become foundation of industry. But there's also many disciplines outside of humanities which have been explicitly, implicitly studying culture using big data, right? So from computer science, to computational social science, to psychology, to urban planning, to even data visualization, data art. And this is just some examples from the last few years, right? So there's a paper where we're looking at the diffusion of trends using 1 billion Facebook photographs. There's a whole literature now where people are using computational analysis of fashion. There's a project I'll show in a second from New York Times, which looks at the 50 years of music hits to try to understand how variability of popular music may be changing, right? There's a dimension reduction and visualization of 1,700 music genres. And there's also even analysis of careers of artists. Again, this is not my papers, right? Just to be clear. So I simply want to point out that what I've been doing, right, in my own little corner, it's a part of this huge field, which doesn't really have a name, right? Because this work is done by designers, by artists, by computer scientists. It's done by algorithms inside Facebook, except nobody looks at this work except algorithms, right? So it's a kind of cultural movement, right? Again, what I call cultural analytics is an umbrella term, and it's not limited to any particular discipline, which I think is a good idea, right? So a couple of examples just to show you how in the last few years, this work, sometimes, is really done in very mainstream publications, right? So this is New York Times. It's from a couple of years ago. So we have wanted to look at the evolution of characteristics of popular hits during summers in America, popular music. So we kind of made a list, right, of hundreds of songs, which were top 100 hits according to Billboard, right? Every summer in America, for like 40 years. And then we kind of went to Spotify, right? Spotify, we use Spotify API. And for every song we downloaded, right, various features, right? Because as I said, right, the media industry is based on media analytics. So Spotify, and right, other kind of music streaming services, we all have 30 to 50 million songs, and we all extract features from the songs to use the recommendation engines and other applications. So now what New York Times designers have done is we visualize each song as a kind of shape in 5 dimensions, right? Loudness, energy, danceability, acousticness, and valence. So now every song gets a signature in a 5-dimensional shape. And now they kind of superimpose, right, all the songs for, every year. And even without knowing anything about statistics, even without knowing anything about standard deviation, you can visually see that, in fact, the variability of songs in each summer became smaller, right? But to make it completely clear, right, they're colorizing it. So they're basically saying that if you look at these 5 features, which of course are not the only features, but if you look at these 5, over these years, variability of music hits becomes smaller. And to me, that's exactly why it's so interesting, right? We use computer science and machine learning and computer vision and music information retrieval to study culture, because you can look at these kind of long trends and you can notice certain slow changes, which perhaps would be hard to notice. And even if you're in the field, even if you're a musician, music producer, music critic, even if you notice this, it would be hard for you to quantify it and to kind of show this exactly, right? So when we kind of make this into projection, project this, right, onto this scatter plot. So on the horizontal axis, you have years, right? On the vertical axis, you have the average measure of how similar or different are all the music hits in America for every summer. You can see that, there is a kind of slow move up, but it's not all bad news, because you can see how in the last few years, the graph starts going down. So we're claiming within the last few years, in fact, variability once again increasing. And this, I'm showing it, right? I'm showing this example as opposed to millions of others, simply to indicate that this work goes beyond academy, that in fact, New York Times, who has a probably best in the world kind of design, right, data visualization team, have also done many interesting cultural analytic studies. You can also find them in places like Vox and in other mainstream media. And then to show you example of more like academic work. And so this is from Barabashi lab. So Barabashi is one of the top scientists in network science. He's Hungarian. He runs like 3 or 4 institutes. Nobody can keep track. His main position is northeastern in Boston. And he can develop a whole field, which is called success studies, because he's a very successful person. He has about 30 people in his lab, right? So he only accepts students and postdocs if he thinks we can publish a paper in Science and Nature. You guys are happy, like some students are happy, right? Just to have like a one-day exhibition somewhere like in the middle of nowhere. No, he says only Science and Nature. So he accepts students, mostly from China, of course. Like, they work for 3 years, and if he can't publish in paper in Science and Nature, he says goodbye, but most of them do it. It takes 3 years, right? So he and his colleagues, because we're so successful, right, and we know how to be successful, we establish a whole new field called, right, the science of success. And here we're looking at the success in art world. Again, I like to show this to make the art students a bit nervous, right? So we work with a team where one of the team members is, in fact, a kind of art world gallery, kind of art world information person from New York. And he, over years, created a database which has about 500,000 of artists. When I actually read the paper, and then I asked somebody in the lab, I said, why in this paper we don't see many mentions of artists and museums from Russia or China? He said, oh, because your database doesn't have it. The paper still got published in Nature, so much for science. So it's not complete, right? But the database has trajectories of 500,000 artists, about 450,000 artists, and you can simply extract this data, right, from artist CVs, right? You can study now the kind of success and the professional life in any field by going to LinkedIn and just downloading people's CVs. But in this case, the guy has a database. And then using a network model, we kind of measured how important each gallery and each museum is, and derived these measures completely from inside the network. So I think we had something like 8,000 museums and 20,000 galleries. So again, according to them, it basically represents the whole commercial art world, but it actually doesn't represent, Asia so much. And then we said, so are there some general patterns in terms of artist careers? So that's the summary of a paper, right? So again, paper was published in Nature, just to show you with even Nature, you can now publish work on culture, right? So it's very interesting, right? It was not possible before because now you can quantify. So the idea is that if you are an artist, and this is again for the last 30 years, so it may be different now because things are changing, right? But for the last 30 years, right? So we kind of generalize the data set. So if you have first 5 exhibition in what, according to the network model, is a kind of low prestige place, a low prestige gallery, most likely you will never go up. Most likely you will stay in this kind of low prestige to middle prestige world, right? So as we can see, out of people who had very first 5 exhibitions in these low prestige places, in low prestige, it doesn't mean it's not a question, it can be a great place. It's just not so many nodes go to this place, right? So it can be like amazing place, but it doesn't have lots of connectivity. You know how like when you search the web, at least in English, typically you always get Wikipedia page because so many other pages link to Wikipedia. So Wikipedia becomes a very high prestige place, right? So, right, so your chances, in fact, of making it to the high prestige places are like 10%, right? Right? Okay, whereas if you start like in a kind of high prestige galleries or other exhibition places, maybe Kunsthalles in Europe, well, most likely your prestige will go up, but again, only literally 0.2% people end up at the bottom. So that completely changes what I thought about art, the way I was taught, right? What I learned in New York in the 80s when I was there, right? Typically you start in some non-profit places and you have your exhibition in your friend's apartment and one day you make it to the MoMA. No, you don't. Okay? So again, it's a very interesting example here, how using big data and using the tools, in this case of network science, you can kind of find some patterns which in fact go against the accepted myths of, and we accept the understanding of culture. Okay, Um, so anyway, as many of you know, right, outside of New York Times, outside of network science, right, most of research on culture today is done inside companies, but they don't publish it, right? In fact, nobody looks at this research because it's done by algorithms, right? Always done by computer scientists who publish in the areas like artificial intelligence, including computer vision, right? Multimedia computing, music information retrieval, search engines, and so on. And the amount of this research is very big because computer science is so big. So what I like to do, just to kind of see what's going on, I go to Google Scholar, right? So this is like, I think, last year, and I type Instagram, and then to find like more quantitative articles about Instagram, I put things like data set machine learning. So I get like 8,000 articles, right? So I think in 2012, me and my student collaborator were first ones to actually publish a study of Instagram, scientific conference, and now it's 8,000 papers. And then there are always like areas, right? Or for example, there is a whole area which studies behavior of tourists. So here we have 19,000 papers. And then there's a whole area called static computing, right? Which people, if there are people here who connected to IM, you know about it. So the idea is to use internal characteristics of an image, right? To measure kind of image features, and maybe also like likes and so on, and to try to predict why some images get more likes, some images get less likes, right? So basically try to kind of take the 1,000 years old study of aesthetics. People wonder about beauty, right? What makes something beautiful, what makes something likable, and quantify it by using big data, right? So here's 10,000 conference papers and publications on static computing, right? Now, so as I said, 15 years ago, I had this wild idea. Now there's 15 years of research where Italy, depending on how you define it, right? If you look at study of culture in a very narrow sense, you say, what are papers actually doing something really interesting? Like, for example, this New York Times project, right? Or Brabashi paper, which are really asking very directly cultural questions. Maybe there is tens of thousands of studies. If you think about every paper about, Facebook recommendations or, people behavior on Twitter as culture, when we're talking about millions, right? And as I said, because of progress in software, because now there are always libraries, right? Python and so on, right? There's high-end machine learning tools, right? Torch, and also the computers are so much faster. This very utopian idea, which I had 15 years ago, is still utopian, but it's a bit less utopian today, right? So the goals which I defined for myself in 2005, they didn't change, right? And I would define them like this, right? So what are the themes, styles, behaviors, and patterns in contemporary global culture, right? Notice with digital humanities, we can focus on history because humanities are focusing on history. People who study contemporary culture in cultural studies, which is not clear what cultural studies is it humanities, social sciences? Yes, of course, there are people who publish in fashion studies, design studies, but at least in the English world, right, most humanities people teach history, and that's a good thing. If somebody should teach history, right? This history was fantastic. But I'm focusing on contemporary culture because I'm a contemporary person, right? And that's what I want to understand. So then the question becomes, what are the spatial distributions, right? For example, what are people sharing in Lucerne versus Zurich, right? Between different ages. What are the kind of artworks done in one art school in Switzerland versus 5,000 art schools in China, right? Our particular, yes, we have now global culture with a 30 years globalization, but does it mean that everything is the same? Of course not, right? I'm now staying in South Korea, right? So South Korea is very global, but it's a completely separate place because Asia, with different aesthetics, right? Different sensibility. The most modern buildings in Korea are built by famous European architects because they're too primitive, right? Because we don't understand 100 shades of gray. We don't understand minimal space. They're simply too simplistic, like MRVD, right? A cafe built by local Korean students is way better than built by Rempolas, right? It's a different culture. So if I can make this map, if I make this giant dictionary of motifs, patterns, trends, and so on, almost like iconography by Panofsky, so to speak, right? Okay, what are the distributions of these patterns, right? What do we have where? And then how do these patterns emerge, diffuse, change? So basically, if you think about culture using metaphor of geology, right? I want to have this complete, super detailed time-space motif kind of interface, right? To show me how culture on this planet changes. And in fact, there are probably 3 disciplines which inspired me to have this vision. So one is so-called cientometrics. So cientometrics is a discipline which measures development and impact on science. Maybe you heard about journal ratings, right? So these ideas were developed in America in the late 50s. That you can measure influence of journals. You can also kind of track development of scientific ideas. But it only works in science because science has a very rigid system for quotations, right? Everybody quotes somebody. The only part of culture which has a system is music, right? So if you're doing commercial music, you have lawyers who are going to clear the samples you go to sample. But of course, in humanities, in architecture, in art, in cinema, people quote each other all the time. But this is not, right? This is not kind of formalized. So if you can formalize it somehow, right? So, but then what is the quote, right? If you change something 1%, is it the same thing or not? But the cientometrics, the bibliometrics, it's a very good inspiration. The second inspiration comes from evolutionary biology, of course. And why biology? Because in humanities basically modern humanities developed in the 19th century. In the 19th century, it's a century of classification. People obsessed with classification, and we use language to classify. So you go to Museum of Modern Art in New York, and there are departments of painting, drawing, sculpture, works on paper, and new genres. And the same thing if you go to most art schools and design schools. Meanwhile, for the last 20, 30 years, we live in a remix culture, right? Everything is remixed, different media, multimedia, and so on and so forth, right? Interactivity, but we don't have a vocabulary for this. So what I like about evolutionary biology is that today biologists, we distinguish something like 100 million species on this planet. Now, the concept of species itself also gets questioned because it turns out the species was another 19th century invention, which is like a bit limiting because it's hard to say where one species ends, another species begin, but at least it's a start. So So I'm not saying that lab is against categories. No, I'm not against categories. I want to have more categories, right? So if we have 55 categories, let's have 5,000. If we have 5,000, let's have 5 million. So if you believe in this project of creating categories, if you believe in this project of describing modern culture into a species, so how many different species of images we have? Content, composition, mood, and so on. Right? So if I take 1 billion images from Facebook, random sample, right? Is 5,000 enough? Is 1 million enough? And finally, my last kind of discipline which inspired me is geographic information system, because as you know, geographic information system like Google Earth, right, or Microsoft Earth is a good example, so NASA Earth, right? You have different layers. So you can look at the same area, and you can have layers which can be representing water, buildings, geology, and so on. So you can imagine that we're looking at Earth culturally, kind of semisphere, and we have these layers representing different levels in culture. So now we have basically enough data, and if you give me, right, if you give me $5 million or $2 million, I can build it for you. But I don't want to anymore. So the question is why? So now I'm going to present to you, right, the main idea of my talk. What I see is the main challenge in studying contemporary culture and also historical culture using data science. The challenge has to do with the fact that we have no idea how to use big data. We have computers, we have Hadoop, we can process billions of rows a second, right? Facebook can process trillions of interactions, right, a day. But at least theoretically, we're treating big data the way people were treating data in the 18th century. Yeah? So what we're doing is we're continuing what I call statistical paradigm, yeah? Statistical kind of worldview, which emerges in the 18th century, before big data, before computers, where the data tables were done by hand, and the great innovation and the great power of statistical thinking in the 18th and 19th century comes from aggregation, right? You replace a country with aggregates. Okay, how much import to export we have in different categories? What is the proportion? What is the right? What is the average number of births and deaths in different parts of Paris or different parts of France, right? You basically replace the world, its individuality, complexity, uniqueness with aggregates. And because you replace 1,000 numbers for 1, million numbers for 5, you have a great power in a kind of Brückle true sense, right? You can move these aggregates, you can compute them, you can combine them, but of course you lose a lot. So, if I read a computer science paper, which says we look at 1 million Instagram images, and for various techniques, we reduced it to 10 most popular subjects. To me, it's an example of this old 18th century thinking. So we're not taking advantage of the fact that our computers don't require us to reduce anything. Okay? You guys hear me? Everything's okay? Hello?
Yes.
Yes, good, right? So let me just a second. Okay, let me just try to, just a second. Let me just try to move it out of the way. Okay. Yeah, I'm looking. Sorry, okay. So this is, so basically, shall we aggregate big cultural data and reduce it to a small set of patterns, which is what I wanted to do 15 years ago, right? Frequently occurring ideas, themes, styles, patterns, behaviors, right? So this is also paradigm of 19th century. This is Marx, reduces society to 2 classes, right? Maybe this is Freud, who reduces kind of cognitive and life to just like 3 levels, right? Conscious, unconscious, subconscious. This is contemporary social science, right? Which reduces society to few groups based on gender, age, maybe income, right? So this is what I call 18th century paradigm of reduction. And when data science started to be used in every area of modern society, economics, warfare, and so on, this reduction continues, right? So what we're doing with paradigm is we're focusing on what is common between the number of objects, and we don't include what occurs infrequently, right? So when you think about all the paradigmatic, right, all the basic methods of statistics and data science, cluster analysis, right, dimension reduction, t-SNE, PCA, mean, standard deviation, you basically, either you're calculating statistics by categories, or you are basically calculating averages, average tendencies, right? And or like you cluster data into clusters, and whatever doesn't belong, you kind of, right, you throw away. And my point, right, and that's kind of maybe I'm completely wrong, right? But that's what I realized 10 years after I spent 10 years, right, working with projects and studying data science from scratch, is that maybe we don't really know how to use the data in a new way. Yeah? So what would be alternative? Alternative would be to refuse this dominant paradigm, and instead focus on diversity, variability, and differences, including tiny ones. So to work on big cultural data without aggregation. Now this sounds wonderful, but it also sounds beyond maybe human reason, right? So if I want to look at 2 billion images shared to the Instagram, right? I know, or 1 billion artworks shown in all the galleries today, or every single cafe in the world, right? Or every single every single kind of fashion design today available in the market, right? What if I don't cluster it? What if I don't group it? What if I don't categorize it? But I only describe this huge field in terms of differences. Well, Lev, you can say this is completely, completely crazy, right? It's completely unreal, but why not? Humans have spent a couple of hundred of years developing intellectual and tools and also technologies to help them categorize the world, right? Intellectual categorical systems, right? Genres, Library of Congress, subjects, cluster analysis, and so on. Why not now spend some time to uncategorize the world, right? Ungroup it. So this would mean we have to include everything. This will mean that you have to pay attention to the frequent, but not outliers, because the whole idea of outliers versus the main versus like the key data, it's a bit of a binary. It also means to identify small cultural islands, which usually disappear when researchers use domain paradigm. And it also means something which sounds very, very scary, right? Because as I said, to me, the key idea, right, of contemporary kind of data science is similarity, right? You group users, music, images, products by similarity, right? But we have to question similarity, right? We have to question the ideas of categories, clusters, dimension reduction, so on. So these are basically my challenges, right, to the next generation of researchers and students. How to use big cultural data about aggregation, how to think about categories, how to learn from computers to understand the world differently. Douglas Engelbart, right? Douglas Engelbart and Licklider, right? In the 1960s, we said we want to use computers to augment human intellect. And people have built, right, for 50 years computer technologies which augmented. Now we have to do something else. Now we have to build computer technologies which will make us to see things differently. We have to basically learn to look at the world as aliens, not as humans. And finally, how to work with big data about numbers. As I know, like I see that we're getting close to an hour. So just very few examples. So this is just selection of Instagram posts I made, right, from various Asian countries and Eastern Europe, and we have like 4x4, right? So 4 images from different Instagram users. Yes, you can find some cliches. Yes, you can find some compositions. Yes, you can find some common motifs. But every image is unique, right? So the moment you start clustering it by 2, by 4, by 6, and so on, it doesn't matter if you cluster, if you use t-SNE, if you use machine learning, if you if you use ImageNet categories, you lose information, right? You lose meaning, you lose something which is crucial here, right? So it doesn't work. Now, what's interesting here is that if you actually look at how machine learning and AI are used in the industry, we actually use that in a different way, right? So, for example, right, ad platforms make predictive models for each user for different times of the day and make custom recommendations. Search engines, right, index every page we can find. Spotify and other companies analyze every music track. So at least on the level of analysis done by companies, intellectually, they're actually more progressive than us because we are taking into account every web page, every track, right, every image and so on. But of course, what all we can do is to recommend to you something which already exists. But now we have, right, more and more AI creation, AI generation, GAN, and so on. So maybe we'll see more and more creation where you have extreme individualization, right, extreme customizations, and the cultural products will be customized to you. Very briefly, right, maybe, can I have like 5 more minutes? Yes?
Yes, absolutely.
But yeah, okay, so very briefly, just show you, right, a bit, just few more slides and basically a few examples from my work. Now, it took me about 12 years of working with kind of cultural data before I started to have these very theoretical ideas. But maybe I was trying to do something like this intuitively because I was coming not from data science, not from humanities, but from the arts, where I used to work on one image, right? But first, some more difficult questions. So we know that classical categories are problematic because we don't allow to see differences between category members. So continuous measurements of features using data science are better because we represent similarities as numbers. So in general, right, the data scientists give us a better language to talk about culture, but how do we know we have the right features? Right? So how do we know we extract these features, which in fact correspond to what your cognitive and perceptual system is seeing? We don't know how brain combines features, right? We also can think about Gestalt theory, right? So Gestalt theory tells us that the whole is not a mechanical sum of parts, right? So this is why you can extract 1,000 features, you can extract 500,000 features from your image, you may still miss what this image is about. And finally, the images or our artifacts may be completely identical from statistical point of view. And yet we can have crucial differences for human observer. Tiny difference would make a difference. So imagine a fashion photographer, right? And you're being sent to photograph a model or a famous writer or whatever, right? You take 800 photographs, and then you bring them back to the office. And then the editor is going to put these photographs on the wall, you know, like the Vogue editor, for example, right? Or book editor, and they're going to look at them for hours and select this one photograph. Probably if you measure every possible statistics, you will not even see any difference between image one and image two. And yet, because we're humans, we have, you know, bodies, you know, we've been in the world, you know, there are billions of neurons, because we have general intelligence and computers do not, right? The computers don't have artificial intelligence, we just know how to classify, right? And etc. Right? The general artificial intelligence remains a kind of myth. You know, we don't know that, right? So the computer will say, well, you know, I can show you any of these images because statistically we're saying, you'll say, no, this image is actually what I need now. So what we try to do very briefly in my lab is to build tools which will use features, but not immediately kind of plug them into classification system or regression systems, but basically use features to try to display large image and video collections where images or videos or video frames are grouped by similarity, but at the same time, right, because they're displayed on a kind of big visualization wall such as this one, you can still see the differences, you can still see all the images, right? So here, for example, this is a slide from 11 years ago. So we built a system within our computer lab, and we're looking at visualizations, which I produced on my laptop at the time using software I wrote, which has 1 million pages for manga books. And these pages are grouped by certain visual characteristics. And here we're looking at something else, right? So that's the size of this wall. And in fact, because I was kind of seeing these walls when this institute, Collective 2, opened in 2005, it led me, right, to this idea of being able to compare any number of images and videos. You know, and this is this visualization, right, of 1 million pages of manga. It took 48 hours to compute on like iMac in 2010. The software is called Image Plot. And of course, it's also reduction, right? So I never left the reduction paradigm. So it's also reduction, it's also aggregation, because all the pages are sorted by two visual characteristics. So the X characteristic, the X dimension is not very interesting, it's standard deviation. And the Y dimension is interesting. Y dimension is basically entropy, right? So these are the close-ups. So on the left, you have close-up of the top of this cloud. On the bottom, you have a close-up of the bottom of this cloud. And this has two extremes, right? So if you have low entropy, you have very images which are not lots of detail, very kind of more abstract, not lots of labor. In the images on the left, right, lots of detail, lots of texture, lots of labor. And what I thought when I first kind of rendered this in 2010, I said, that's amazing, because I expected to see clusters, right? I expected to see categories. Instead, I got this continuous field. So at that point, I can use this, this one image to make this, I think, very arrogant suggestion. But in fact, if we start looking at a very large collections of cultural images of our artifacts, maybe we'll find that the categories such as style do not really work, because we'll find every possible variation. Of course, later I realized that this is not completely true, because there are maybe categories having to do with iconography, how eyes are rendered, and so on. And of course, we're only looking at one dimension, but also what I realized later on is that the fact that these methods allow us to see culture in terms of continuous variation is partly artifact of these methods, right? Because as opposed to classifying it using language, you can say this is one style, it's a second style, it's a third style, and so on, right? You measure these differences, you get continuous scale, and then you get this continuous distribution of images, right? So if using natural language, German, English, Italian, Chinese, and so on, to do our history, cultural theory, and so on, forces people to use categories. very primitive one, like globalization, late capitalism, postmodernism. So these categories, of course, are useless because they're too general. These computational methods have their own limitation because, in fact, they dissolve categories and everything becomes continuous. So I'll skip this one. Okay, this was our project, which maybe some of you know, which we did in 2014, trying to create now not our own visualization, but create an interactive interface. So people themselves can sort images by different characteristics, right? So I'll play this video really briefly. So this was like 2014, so we had to explain to people what selfies are because we didn't know yet, right? Especially art people, So we collected a database of selfies in 5 different cities, and then working with Moritz Stefaner, who got more awards for data visualization than any designer in the world, right? He created these visualizations where we look at selfies, in fact, actually using categories like gender and age. And also, but then we also measured emotions, right, using computer vision. So basically, and then we created this interface called self-exploratory, which still runs even on your phone. So on the top, you have various graphs which represent distribution of different features, emotions, mouth, moods, mouth, head orientations. And then what you do, right, is you kind of make a series of selections in the database, and the system shows you which images can fit with selections. So I wanted to make it as a kind of one possible general interface for exploring any image collection, but we didn't have a budget, so the software was only designed to work with data sets, but I think the idea was still good. And then we, same team, we made another project called Broadway. So here we wanted to represent a city using about 40 million data points. So we kind of reduced New York to kind of corridor, which is Broadway, right, the longest street which goes from New York. And we tried to collect various data along Broadway, like 100 meters along Broadway. So we got about 14 different layers, landmarks, Google Street facades, we extracted facade colors, we got taxi statistics, social media statistics, income data, and so on. And this is the data, right, represented as a kind of graphs, right? So this, the graphs going up, it's a Times Square. So most of the activity around Times Square. So like 13% of all tourists go to Times Square. And of course, now you have protests on Times Square. That's why it's still closed after 3 weeks in New York, right? So New York basically is a war zone. It always was, it's just now more visible. But when we can build this interface, and again, the idea was to create an interactive interface, which will allow people to zoom out and get overall view of a city, compressed, aggregated, right? Because aggregation, compression, summarization are good because you can see the whole thing. That's what Maps does. And then you can also go in and kind of using your familiar gestures, right? You can kind of zoom out and navigate the data one building at a time. So again, obviously we never solved this huge problem, right? How to compare millions of artifacts without aggregation, and maybe it's a wrong idea, but what we try to do is we try to create visualizations and interfaces which will at least combine the advantages of navigation, of summarization, aggregation, and reduction, and also the ability to look at the data in the more zoom level, look at each image as a tile, and in fact to notice differences between images as opposed to reducing them to categories, clusters, and so on. And finally, maybe just 2 more minutes. So after about working, right, with images from 2008 to 2017, we work on about 42 data sets in my lab, and then I realized, okay, I'm now hitting with that end. So just as in my late 20s, I realized that I'm hitting that end with semiotics and psychology of art. I realized that I'm kind of hitting with that end with current data science, because as I said, right, what I realized is that, yes, computer vision is wonderful for many practical tasks, and computer vision is built in into Photoshop, Luminar, right, all these wonderful tools, and it's getting better. But as a tool for understanding the subtle differences and the subtle nuances of visual culture, on the scale of billions of images, maybe it's not quite there yet. So I said, I'm going to take a break and maybe go away for another 20 years or, and come back. And I decided to actually do something very different. I said, I'm going to continue cultural analytics, but not looking at artifacts like images. I'm going to look at events. So the idea is that over the last 20 years, the number of cultural events in places have become so large that we now have become big data. So so I got the funding at the university in the middle of Siberia. That's a whole other lecture. It's very, very surreal. 2.5 years of my life, sleepless nights, and so on. I hired a company in Moscow, and we collected a data set of about actually 4.5 million events, like including a few million meetup meetings, 1.5 million Behance projects, eFlux, and so on. And the idea was to, again, do a kind of cultural analytics, as I wanted to do 15 years ago, but do it on a kind of smaller scale. So not try to map trillions and trillions of artifacts and look at their distribution in terms of subjects, iconography, and so on, but simply look at the topics using text analysis, what topics have been discussed where, what events are taking place, in each city. So our data set has 200 countries in 22,000 cities. And in fact, I'm now looking for talented computer science collaborators to help me analyze and write papers about this data set, because I can't do it all alone, right? I think that's the end. So, I mean, I can show you more things, and as always, I took a bit more maybe of your time. I apologize it, but I hope there's still some energy for discussion. Thank you.
Thank you so much, Lev. Wonderful. Thank you so much. Especially seeing the kind of context of the way you were thinking about this over time, from the kind of semiotics is a dead end, which you really feel when you say this, and the struggle to kind of move to another space, and a transdisciplinary space, in order to understand something that ultimately is modeled in very radically different ways by different disciplines. To your attempt, I loved how you were saying how you were even trying to create a movement without a name.
Yes, exactly, yeah.
So there were some questions already in the
wonderful
discussion.
question, yeah.
And I'd welcome everyone to gather their thoughts as well. And
well, I see some questions which are absolutely superb, and that's why I felt I can go like I can really kind of do this talk in the kitchen. Yeah, and I did something different, right? Because I thought I'll spend more time kind of talking about my trajectory, because maybe it's not clear how this ideas of cultural analytics came out. In fact, out of my frustration and inability to understand how the single image works. So when I said, okay, I don't know how single image works, nobody knows. I mean, not completely, right? That's why Roland Barthes writes referred meaning, right? Because in 1970 he's also stuck, because semiotics, you can say it's like another digital humanities project was called semiotics, right? And then I said, okay, I'm now going to spend 15 years working in media, so to think about the concept. So that was done. And I said, now I can come back to this project of thinking about images, but since it's too hard to think about one image, I'm going to think about trillions of images, right? And just to kind of figure out what's where, right? But even this also turns out to be too hard, right? So let me look at some questions. Do you have a preference which questions I should go at first? Well, wonderful. Like I see by Burke and I see by Jonas, or maybe something else.
Johannes asked the first question.
This one, right?
Picking up on the main challenges.
Yeah. Yes. Okay.
Should I just read it up so everyone knows what?
Yeah, please. Yeah, sure.
Okay, Johan's question is, picking up on the main challenges you point out at the end, the crucial question to me seems how do you, 1, decide on, and 2, define the handful of parameters you consider relevant, with reference to Foucault's argument in order of things. The choice of parameters will, of course, direct the findings, much more regardless of the amount of data you look at. So how to circumvent the problem of parameters being 1, reductive, and 2, already anachronistic when applied. How to take feedback and retroactive structures in culture into account.
Yeah. Obviously, okay, so obviously I don't have an answer, because if I answer like, I mean, but, everybody can give you an answer. I want to give you a question. Let's what's important is not to give you an answer. What's important is formulate the right question. Okay, so first of all, right? Okay, so first of all, right, so we can basically, so before 2013, right, before neural networks became like a new fashion, people were using so-called manually crafted features. I found out that manually crafted features are more useful for cultural analytics because somebody like, Van Gogh or Picasso, right, they think in terms of color or lines or shapes. So if I'm looking at their art into the evolution of lines or color shapes, it's actually meaningful to them, right? Whereas, of course, if I'm doing like neural networks where I have low-level features and I don't know what we do, right? Because I remember neural networks, 2013, right, became famous because of classification and detection. And then, like now, when we applied, right, we can do t-SNE and so on, but that's not what we're designed for, right? So this simple low-level, okay, so first of all, features which we want to use are features which are meaningful to creators, right? So to modern art, what's meaningful is color, hue, composition, shapes, where, for example, Van Gogh, right, makes his brush strokes versus Soutine, that's all meaningful, right? Now, the second thing is, again, if you look at these features people used before 2013, right, so there are, hundreds, so you can make dozens and hundreds of features, and potentially, right, they're all relevant, but what is relevant in a given sense depends on what is your question, right? So in computer vision and machine learning and industry, the questions are detection, is there an instance of a chair, right? Categorization, what are the different type of objects I see in the scene, right? Or what is the type of a scene, is outdoor, indoor, right? Or maybe like, et cetera, and so on, right? Okay, what pose estimation? Well, the human vision is not computer vision, right? The human vision has thousands of different purposes, and thousands of different nuances. These nuances are described in thousands of years of poetry, literature, painting, and so on, right? And the art creates new modalities for what we see, how we see, but so is design, so is fashion. And we don't even know how we operate, right? So we don't even know what the task is. For me, the question is, but I want to bring it down to something more manageable, right? So the question which I want to ask, right, is, okay, so I'm going to go and look at, again, 1 billion or 1 million or even 1,000 images people share today. Let's say they're photographs, let's say it's on Instagram, but it can be, it doesn't matter, art images, we don't like Instagram. Instagram is more diverse, but whatever you want, right? Well, so I want to reduce them to some kind of clusters or categories. But every time I reduce something, I lose something. So it's a meaningful project, right? So I kind of want to make a project, maybe somebody wants to help me. Like I start with 10,000 artifacts and I cluster by 2. So from 10,000, I go to 5,000 and I immediately write down what I lost. And then I keep going, right? So instead of basically showing you by amazing findings, which I get as I can do with hierarchical clustering, I want to uncluster and I want to show you, I want to understand what is lost at each level, right? So maybe I'm not completely answering Joanna's question, but I don't know how to take feedback in interactive structures in the culture. That's maybe we need like 1 year to think about it. But basically, what I want to say is that the features are fantastic, right? The features can be low level, high level. The question, what is the task? And the culture has thousands of tasks, and the task defined by industry, which guided computer vision over 70 years, with just a few things, right? And that's what animals do. Humans have aesthetics, so we do something else. And can I just say one more thing very briefly? Very briefly, I just want to show one thing of you about also aesthetics, right? Just very, very briefly, it will just take literally 1 second. Let me just figure out where it is. Just one little second, it will be. Okay, maybe it's just 1 second. Here it is, right? Yeah, so this image. So, in 2014, IM, was I think one of the first, I'm not sure, one of the first, maybe the first company, which published, right, their work on aesthetic scores. So that was a new, right, frontier for computer vision to go beyond classification, detection, recognition, and also describing, right, what we see in the image using language, right? You know, and I took it, right? So I took it from a company demo from last year. And on the one hand, right, it's very, very interesting, right? That using machine learning, right, we can take lots of images and we can see what kind of scores or number of likes, right, or other signals which users have given us. And then we can calculate with statistic scores, right? So the image in the left got a statistic score of 85. The image on the right got a statistic score which is much smaller. And maybe already the company and also other people are going beyond that. I haven't seen these papers, I haven't seen these demos. The problem, of course, with research at that point was that you're treating all humanity as like one category, right? So if you're basically taking millions of images and their likes, you don't know who are people who gave us likes. What's their education? What's their gender? Do we live like in Lucerne or do we live like, you know, I don't know, in Shanghai? And what we know, right, from humanities is that there are subcultures, right? There's tribes. You know, what you like or not like depends on your education. In fact, it's been proven in psychology of art over decades that the way people who have art, design, education are looking at images is very different than normal people, right? So people who have art, design, visual education, they actually see structure, they see kind of form, you know, and that's why we like abstract things. Although it may be changing, right? Because maybe people get educated on Instagram. So the problem, right, with kind of calculations is that it will be better to calculate it for lots of different categories of users, right? For lots of different audiences, not just one. Because if you use like a big data set, you don't know who these people are, you draw it from a web. Basically what you're doing is not studying culture, you're studying mass culture. So you're studying pop culture, right? So this is the average people who didn't go to art school, who didn't go to your college, you know, and who like things which are bright, right, colorful, saturated, and not something else. And I think that one thing which we need to do, right, and that will be already a step forward, is to start, right, thinking about these more specific audiences. And again, what I see is a contradiction between these kind of theoretical conceptual models and actually what happens, right, on the web, you know, where the recommendation engines, they recommend a particular thing to me based on my browsing history, right, and based on other. So in fact, you know, the some recommendation engine doesn't classify, right? It actually gives me something very, very particular based on my browsing history without even putting me in some category, right? Sorry, maybe I spent too much time, but since Katrina mentioned, right, with maybe people here who have some connection to, you know, the company or the company DNAs, I wanted to mention. So it's both fascinating, I love it, but it's also problematic. And I'm not this kind of humanities person who says, oh my God, we're going to quantify statistics. No, great, let's quantify it. Let's just do it much better than this, right? That's not good enough, right? So sorry, Katrina, for this kind of rave, but I thought where else I can get into the nitty gritty of this kind of these details, right? Okay, let me just stop sharing here. Okay, so was another question about yeah, trading out. Well, okay, so when you talk about thinking about categories, right, aren't you just trading out categories for very categories? Well, you know, I don't think so, right? I don't think so. And again, what I want to point out is that it's not about reducing, it's not about getting rid of categories because it's impossible, it's multiplying categories. Again, I'll give you an example. So traditionally, we think of science or research with biology, physics, with natural sciences, right? So we're using a few hundred categories, right? Okay. So in the last 10 years, we see certain papers where people use, again, science, you know, people use, right, you know, the big data, where we look at 10, 20 million papers, and they, right, again, use standard data science techniques to represent these papers as a kind of map of science, maybe you see this map of science, where you have thousands of paradigms, and the paradigm is simply a bunch of people who refer to each other, right? You know, and then it turns out that this map of science is more precise as opposed to our traditional maps based on kind of top-down categories, right? You know, so in this case, this more precise map, it doesn't reflect something which is from a computer. No, it does reflect the content, right? So if I make a map of, let's say, types of images or types of compositions, right? Or types of, I don't know, feelings you get when you go to concert today. And if I have map of thousands of these feelings, that's not something a computer import. No, it's actually going to be in the data. The computer is simply going to facilitate for me to map it out in a way which is more precise than I can do myself, right? So I disagree with this question here. So I disagree with this, that it's only something comes from a computer. You know? The computer will do whatever you tell it to do, you know?
Lev, I don't know if you've seen, there's further questions.
Oh, no, I haven't seen yet, yes. Okay, yes. So which one?
There is one, I'll just cut and paste it from earlier in the...
Please, yeah, please. So I will try to be very short, like I will try to be like yes or no.
Okay.
Bert's question was next.
Oh,
Katrina.
he just answered Bert's
question. You want me to read it? Pardon?
Wolfgang, he just answered Bert's question.
Oh, sorry. Wait a minute.
So
Go ahead, though.
The next one. With the current data sources and computational tools, would you actually address the embodied perception / cognition of the visual? How to actually build up an analytical framework that takes into account the very situated nature of our perception and interpretation without falling into the temptation of ideological frames?
You know, you want me to solve it, right? There's probably like a million people in neuroscience who's spending trillions of dollars every year. I mean, you guys really, I appreciate you guys think that I can solve these challenges like in 5 seconds. I appreciate it, but I don't think I can. So I think we embodied, I think we embodied nature, right? We embody nature, it's important, but I want to take it a bit larger, right? I think that, and again, this is not a new idea, right? And it doesn't start with Dreyfus in the 1970s, his book, What Computers Can Do, right? It goes much earlier, you know, that even if you're looking, right, at the completely abstract images, at completely abstract patterns, which of course constituted maybe 90% of human images, right, in the history of humanity, because yeah, you have portraits of kings, but mostly you have patterns, right, on clothes and so on, right? You know, with completely abstract patterns, right, they speak to us because we have a body, right? Because, you know, there's a horizon line, the body is vertical, you know, right? Things are outside and so on, right? So even I think perception, right? Even kind of in the human culture, even with most simple kind of science stimuli, right? We're functioning. It's not simply, right, because we follow some aesthetic rules. It's not simply because you can compute something inside, but ultimately they kind of, I don't want to use the word meaning because it's an idiotic word, right? Because most culture is not meaningful, right? I mean, what music videos are meaningful, but you know, your design on your key wallpaper is meaningful. No, it's something else, right? But it's not abstract. It's not decorative either. It's doing something else. What it is, you know, nobody knows. Even Brückle doesn't know, right? Even Wolfgang doesn't know. You know, but even with very simple things, you know, I think we humans create them not only because we can please, right, human perception and our desire to have something complex and something variable, but there's something else, and that has to do with our bodies, embodiness, you know, child, mother, you know, inside, outside, details, and so on, right? Basically, our whole kind of human having a body, frames, cognition, history, DNAs, and so on and so forth. So, again, we're not even close, right, to beginning to work on general artificial intelligence, right? We have made great progress in a few problems because we have big data, and big data can have structure. But of course, there is no artificial intelligence, right, for now, right? It's just machines, you know, which find patterns, right? So, so I have no idea, right? That's why at the age of 28, I left PhD program in psychology because I said, in my lifetime, there is no way we're going to find anything which I can use, right? So sorry, guys, you know, but seriously. Yeah.
Lev, can I just take up one question which goes back to this question of categories that seems to be obviously the essence of your talk, and also coming up in the questions a lot, and this idea that computer vision somehow, or the machine can somehow escape human categorization and art historical categorization. Yeah. And I think Nicola, one of the people of the research team, was saying, how do you explain the resurgence in machine vision of rigid traditional categorization schemes? And he's specifically talking about how ImageNet, for example, you know, one of the most significant data sets of computer vision is actually based on WordNet.
Yes, exactly. Yeah. Well, you know, but I want to say one thing. Okay. So is your group, are you guys all humanities people? Because all the questions have humanities kind of, you know, you're coming, like the questions, if I'm a computer, it seems like you're coming from humanities, not from inside. So you're looking at it a bit from outside, because you're using words like resurgence. Well, what rigid categorization disappeared? Maybe it disappeared in the university department, in humanities university department, but not outside. So like it's this idea that things are resurging. No, I'm a bit wondering. You know, do you have any computer science people on your projects, or only humanities people?
Well, we've got the head of the computer vision lab in Lucerne, who's just appeared, Sabine Sustrup.
But too late now.
Missed your talk. She's just popped in.
Okay.
So there are people here from
obviously, I was not important.
She's just waving.
Okay. No, Lev, you're important, but unfortunately, this
is okay. So kidding.
I'm somebody else's talk.
No, that's okay. It's okay. But I'm just like, I need your help, you know, because the questions I'm getting were very good, but we're a bit like, I would say, we're not precise enough, because we're coming from humanities, and you know, like. For example, asking me like, how can I deal with embeddedness of human kind of intelligence? I'm like, well, how do I know? Like, you have 1 trillion neuroscientists for 60 years who don't know, right? And 1 trillion computer science people. So I was kind of, you have to help me, right? You have to help me. We think about ImageNet. Can I tell you something very funny about ImageNet, right? So once I looked at ImageNet a couple of years ago, it was very strange. Because if you start going inside ImageNet categories, you have a category like linguistics professor with like 5 images. You have philosophy professor. So ImageNet was amazing, right? It was amazing engines for progress. But inside ImageNet, there are some very strange things, you know. I don't know why. But now, of course, you have our, right? You have new ones for videos and so on and so forth. So, which question you want me to answer?
We're just going to ask you some very quick questions because we're heading towards the end of our time. So another one that's just popped up, you mentioned photography curators as an audience for your book. How do you think your research and work with cultural analytics can challenge and push the agendas of photographic institutions? Which is coming back to the context of the research project. Okay. Thank you, guys.
So, you know, guys, challenge and push, that's a really cliche words. Why do you have, you know, there are good institutions and bad institutions. There are smart people and not smart people are going, you know, that's the idea that all photography institutions are not good enough and I have to push them. No, they're great people, you know, they're great curators, you know, great people, you know, great magazines, you know, it's like, why do I have to push them, you know? In fact, I was pushed, right? I went to like the photo convention in Europe 2016, and my whole worldview, I learned more about photography from 1-hour demo of professional portrait photographer when all humanity books in my life. You know why? Because the photographer, right? So he's demonstrating there is like light, you know, Kodak lights, this light. So he puts a model, and then like he starts photographing model and demonstrating different lights, and there's a monitor behind him, so you see a photograph. So after 5 minutes, he sets this light, and he makes a photo. And here is me, who've been studying art since age 13. I've been teaching art for 28 fucking years, right? Sorry. And you know, I know stuff about photography. And in this moment, I realized I know nothing. And none of you knows nothing. You know even less. You know nothing. You know now. You know why? Because you don't know how to make good images. He does, or she, right? So after 10 minutes, you get this perfect image. You know, And then he spends 2 hours making it better. And what he realizes is that these people, fashion designers, chefs, photographers, they have categories, we have language, we have tacit knowledge we have no idea about. And that's why computer vision is not going to help us very much, because if we don't know, these people of course don't know. So he spent 15 minutes asking a model to move her neck, literally adjusting it by millimeter. Then he spends 15 minutes like adjusting the shadow here. And I'm like, right, I'm like looking at this, I'm like 56-year-old. I said, I'm like supposedly this like Manovich. I said, I know nothing but images. Okay, so the point is that, you know, people who know, they're professionals, and that's when they realized that cultural analytics hit another wall, right? Because what I realized that if I don't know, obviously Wolfgang and Katrina and nobody else knows, because you guys probably don't, I don't think you know more than me. I mean, we're all in the same boat. And if you don't know, your computer vision colleagues also don't know. So how can we possibly teach computers to make sense of art if you actually don't know how art works? And I started spending my time by looking at the online tutorials for professional photography, lighting, video games, and so on, to try to understand, right? But basically the point is that, sorry, I'm making it a bit of, I know I'm making it a bit of a comedy, but my point is to say that, in fact, what separates, right, really kind of top level, I mean, really professional high level culture from everybody else are these nuances. You know, it doesn't matter if it's fashion or food, you know, or you kind of, right, the way you do like street style, right? It's these nuances, which are they exist, very real, they're not visible to us, meaning human brain recognizes them, but we don't even know what we are, because maybe he can't even describe it in his book because tacit knowledge. And if we don't know what we are, we can't, you know, that's why that's practically all of art theory, art writing is kind of not very interesting because it doesn't really talk about it. It only talks about issues and concepts and pushing and pulling and, I mean, right, it's on the surface. You know, and of course we can't tell computer vision people what to do because we don't know, right? So this is kind of my very dramatic story, how at the age of 56 I realized that I know nothing but images, and if I don't know, I don't think you know, I think you also don't know. So I'm actually now taking photography lessons. So, so that's a bit of a story, right? I don't know if you got my idea, but there's no sound. Yeah.
Wonderful. We have time for one final question, and I'm aware that there's about 3 that haven't been answered. There's one by Peter Jones that was just asked, and if you scroll back, one by Axel. So maybe you can choose which one you'd like to answer as your final.
Yeah, well, so you know, guys, I was because, you know, it's actually, I didn't mention it's late. So when we started the talk, it's 9 o'clock. So that's why maybe I'm not being, I'm like just not being mega coherent. But you know, I just saved the chat because there are some fantastic references. I don't know about Conceptual Spaces book. I can't discuss it because at 10:37 p.m. in the evening. And also, I can't discuss it because I just managed to a bit consult myself and everybody. But you know, the idea, of course, I was simply trying to make a point that the computer tools which we have, right, they're very good for practical tasks. And you can use them to find out, I know, all the faces in the, you know, in the paintings of Louvre, right? But I don't think they're good enough to see the small nuances of culture, but it's these nuances which make culture culture. Right? It's this last 1%. It's what this guy, so in other words, you and me can see what this guy did in 10 minutes, and computer can see what this guy did in 30 seconds, but not more. And even I didn't know what he was going to do for the next 2 hours, right? I think that in our kind of excitement about computers, right, digital humanities, you know, computational history, yes, we can do lots of interesting things. But let's not have the illusion that will become any better than you know, Julia Kristeva, Roland Barthes, or I don't know, Victor Shklovsky, or Aristotle you know, that the art still has a mystery. We still don't know how it works. We know how bad that works. We know how like political art works, which is now often, right? But how real art works, or how design works, or how fashion works, we actually don't know. And that's a good thing, right? So, so which question you want? So that's all I was trying to say, right? That things are not as simple, and computers can help us in many ways, but they're not going to help us, I think, in our lifetime to get at the mystery of art, because you know, that's why we have art, because we don't know how it works. That's why humans keep making art, right? So which question you want me to answer? Sorry, sorry, about photography, but sorry, I have an answer about photography, but it just comes, it's like 10-second answer.
You answered that one.
Well, I think, yeah, no, but I want to say one thing. So, you know what, it's kind of like, I didn't show you, but you know what I'm talking about, this kind of PCA Disney visualizations, right? Where you have images, like I showed you with manga film, right? So you can make much more sophisticated, people doing computer science, right? You know, and you go to gallery, right? Or you go to gallery website, and it's like, you know, you get grids. It's like what is the crap, right? It's 2020, right? So there has been few attempts by few museums over the last 20 years to do something different, but not a lot. You know, so I'm not saying that you have to like hire me, or you have to put these big walls in the museums, but I think, you know, it's good to do something, because I think museums, by putting things in rooms and by giving each room a name, right? Well, this is this, and this is 1920s. In a way, continue with 19th century idea that culture can be categorized and by using language. And I think that you know, it's time for them, I think, to experiment with computer tools. It doesn't matter if it's photography or fashion or, you know, decorative art. I mean, I think it's about time, right? And definitely we can do it online. Okay, maybe we're afraid to do it, right? To do it like in their building because trustees are not going to like it, right? You know, or some conservative patterns, but we can do it online. What else? So perception cognition, I told you I don't know. It's too complicated. Conceptual space is interesting, but not now. It's too important. Maybe anybody wants to ask me like just a live question. Huh?
I think given how late it is now, it's night. It's almost midnight. Is it where you are, Lev?
No, it's not. You know, when I give a lecture in China, like we go for 3.5 hours. So this, what are you guys going to do? Like you're going to go Mount Nilo? What's the story? Let's talk about it.
Everyone, I think there's.
Okay,
I think there's another. I could speak to you for hours, but I'm mindful that there are other people here who have other events in the program to get to, unfortunately. And I think you've left it on a really great point where you're talking something that the students can really take with them, which is to go and experiment with the tools. I think just learn about them, pull them apart, and try and understand them as you have, I think, in every aspect of your trajectory, to see what answers you can find from changing perspectives.
Yeah, well, I think what I said was actually, but I also said something else. Like what they have to do is don't use the current tools because dead ends. Everybody uses neural networks. Don't use it. It's already too late. Right? Go like and draw. You know, like 2B pencil. Right? You know what you have to do is you have to learn as much as possible. Because when you become adult, as you know, right, all you're doing is answering emails, right? So you basically have until about 25 or 30 to learn as much as possible. And when you think about what's going to be important culturally 20 years from now, start working on it. That's kind of what's my lesson, you know, and then things will be okay. You know? So don't think about what's important now. Don't think about this culture after Corona because that's nonsense. Because after Corona is going to be like another virus and an earthquake and so on. No, think about like 15, 20 years. 10 to 20 years ahead, right? 20, for me, 20 work. For me, 20 was a good number, right? So, you know, and question everything and everybody, and especially question fashionable ideas. So if everybody does political art, make good art. If everybody, talks about global capitalism, try to understand that capitalism is a good idea because in the last 25 years, it moved 70% of people on the earth from extreme poverty to middle class, right? I mean, I basically always start by not believing whatever people around me tell me. That's basically my lesson, right? Yeah, don't play with tools, you know. Play with reality. You know? So that's my lesson. You know?
Fantastic. Thanks so much, Lev. If everyone would like to join me in a virtual clap to thank you for your time and your energy and your work. And I'm sure this conversation will continue in many people's work who are here today and in the work of the students. So thank you. Yeah, so again, thank you so much. And sorry, maybe, you know, it was a bit unfortunate because when I give a talks kind of late, it's like I just go into this kind of monologue mode. I basically just had like 1 or 2 ideas which I wanted to communicate, and maybe if I've done it, I apologize if I've done it too forcefully. And actually I saved the chat because the questions were actually fantastic, and people should free to reach me on any of social media platforms, from LinkedIn to Instagram, even Gmail, which is better, you know. And whenever anybody you know, emails me, I talk, and mostly I have conversation with days of 20-year-olds because they understand me much better, you know. So basically, you know, here's the students. Forget everything they're teaching you. Forget everything I told you. It's all lies, you know. And go and look at the world fresh and make the world more interesting, less dogmatic, less ideological, and less political place. Because we have too much politics today, and we don't have enough good art, aesthetics, feelings, and you know, forget about it. World will continue. Thank you so much. Brilliant. Thank you. Thank you. Thank you, everyone.
Спасибо.